Junction boxes are permitted in kitchen cabinets, including those housing double ovens, but specific guidelines must be followed for electrical safety and code adherence. Firstly, the junction box needs to be readily accessible for maintenance and inspection purposes. Avoid positioning it directly behind or above the oven, as heat and moisture emanating from the oven can compromise the integrity of the electrical components. It's recommended to opt for a location above the oven or within an adjacent cabinet to mitigate these risks. Secondly, use a non-metallic junction box that complies with the National Electrical Code (NEC) standards specifically tailored for kitchen cabinets. These boxes are typically constructed from plastic or flame-retardant materials, providing an added layer of safety. Wiring is crucial, so make certain that all electrical wires entering and exiting the junction box are securely fastened and shielded against potential damage. Adhere strictly to all NEC wiring stipulations applicable to kitchen circuits, encompassing the correct wire gauges, insulation types, and grounding procedures. The junction box must be equipped with a cover or plate to effectively prevent any unauthorized access to live electrical components, minimizing the risk of electrical shock. Sufficient clearance around the junction box is essential to facilitate proper ventilation and prevent the accumulation of heat, which could lead to electrical hazards. It is recommended to double-check local building codes and regulations, as these may impose specific requirements for junction box placement within kitchen cabinets. When in doubt, seek the expertise of a licensed electrician to guarantee a secure installation process and full compliance with all applicable codes. In this scenario, positioning the 220 volts junction box in the cabinet above the oven is generally advisable. This placement offers accessibility, adequate clearance, and protection from the heat and moisture generated by the oven. Furthermore, it simplifies the task of connecting the electrical wires to the oven and other appliances in the kitchen. When selecting a junction box, prioritize models listed by a recognized testing laboratory, such as Underwriters Laboratories (AL) or Electrical Testing Laboratories (ETL). Listed junction boxes have undergone rigorous testing to ensure they meet established safety standards. Choose a junction box with sufficient volume to accommodate the number of wires and connections required for the circuit. Overcrowding a junction box can lead to overheating and potential hazards. Ensure the junction box is securely mounted to a solid surface, such as a cabinet wall or frame. This prevents the box from shifting or becoming dislodged, which could damage the wiring. When routing wires into the junction box, use appropriate cable clamps or connectors to secure the cables and prevent strain on the connections. These fittings should be properly sized for the type and gauge of the wiring being used. Make all wire connections inside the junction box using approved methods such as wire connectors or terminal blocks. Ensure that all connections are tight and secure to prevent loose wires, which can cause arcing and overheating. Grounding is a critical safety measure. Connect all grounding wires inside the junction box to a grounding screw or terminal. This provides a path for fault current to flow back to the electrical panel, tripping the circuit breaker and preventing electrical shock. Label all wires inside the junction box to identify their purpose. This makes it easier to troubleshoot any issues in the future. Use a permanent marker or labeling machine to create clear and legible labels. After completing the wiring, carefully inspect all connections to ensure they are tight, secure, and properly insulated. Use a multimeter to verify the voltage and continuity of the circuit. Replace the cover or plate in the junction box and secure it with screws. The cover should fit snugly and prevent access to live electrical parts. Periodically inspect the junction box for any signs of damage, such as cracks, loose connections, or corrosion. If any issues are found, address them promptly to prevent potential hazards. If you are not comfortable working with electrical wiring, hire a licensed electrician to install the junction box. An electrician has the training and experience to ensure the job is done safely and correctly. It's important to understand the types of wiring commonly found in residential electrical systems. Non-metallic sheath cable, often referred to as an M cable or Romex, is widely used for interior wiring. It consists of two or more insulated conductors wrapped in a plastic sheath. Armored cable, also known as AC cable or BX cable, has a flexible metal jacket that protects the conductors from physical damage. It is often used in exposed locations or where there is a risk of abrasion. Electrical metallic tubing (EMT) is a thin-walled metal conduit that is used to protect wiring in exposed or concealed locations. It is typically connected using fittings that are screwed or clamped onto the conduit. Rigid metal conduit (RMC) is a thick-walled metal conduit that provides a high degree of protection for wiring. It is often used in industrial or commercial applications where there is a risk of severe damage. Flexible metal conduit (FMC) is a flexible metal conduit that is used to connect electrical boxes and fixtures. It is often used in tight spaces where rigid conduit cannot be easily installed. Understanding the different types of wire connectors is also important. Wire nuts are commonly used to connect two or more wires together. They are available in various sizes to accommodate different wire gauges. Terminal blocks provide a convenient way to connect multiple wires to a single point. They are often used in control panels and other applications where there are many connections. Crimp connectors are used to create a permanent connection between two wires. They are typically used with a crimping tool to ensure a secure connection. When working with electrical wiring, always use the correct tools. Wire strippers are used to remove the insulation from wires without damaging the conductors. Pliers are used to grip and manipulate wires. Screwdrivers are used to tighten and loosen screws. Multimeters are used to measure voltage, current, and resistance. Always turn off the power to the circuit before working on any electrical wiring. This can be done by turning off the circuit breaker at the electrical panel. Verify that the power is off using a non-contact voltage tester. Wear safety glasses to protect your eyes from flying debris. Wear rubber gloves to protect yourself from electrical shock. Work in a well-lit area to ensure you can see what you're doing. Do not work on electrical wiring if you are tired or distracted. Follow all applicable electrical codes and regulations. If you are not sure how to do something, ask a qualified electrician. It is crucial to understand the concept of grounding and bonding in electrical systems. Grounding provides a path for fault current to flow back to the electrical panel, tripping the circuit breaker and preventing an electrical shock. Bonding connects all metal parts of an electrical system together to create a low impedance path for fault current. The grounding electrode system consists of a grounding electrode, such as a ground rod or water pipe, connected to the electrical panel. The grounding electrode provides a connection to the earth, which helps to stabilize the voltage of the electrical system. The equipment grounding conductor, EIC, is a wire that connects the metal parts of electrical equipment to the grounding system. The EGC provides a path for fault current to flow back to the electrical panel, tripping the circuit breaker. The neutral conductor is a wire that carries current back to the electrical panel from the load. The neutral conductor is typically grounded at the electrical panel. Ground fault circuit interrupters, GFCIs, are devices that protect people from electrical shock. GFCIs monitor the current flowing in the circuit and trip the circuit breaker if they detect a ground fault. Arc fault circuit interrupters, FSIs, are devices that protect against electrical fires. FSIs monitor the current flowing in the circuit and trip the circuit breaker if they detect an arc fault. Surge protectors protect electrical equipment from voltage surges. Surge protectors divert excess voltage to ground, preventing damage to sensitive electronics. When installing a junction box, consider the ambient temperature of the surrounding environment. High temperatures can degrade the insulation on wires and cause them to fail. If the junction box is located in a hot environment, use high temperature rated wiring. Also, consider the presence of moisture or corrosive substances. If the junction box is located in a damp or corrosive environment, use a corrosion-resistant junction box and wiring. Consider the potential for physical damage to the junction box. If the junction box is located in an area where it is likely to be damaged, use a heavy-duty junction box and protect it with a guard. Ensure that the junction box is properly supported. The junction box should be securely mounted to a solid surface, such as a wall or ceiling. Do not rely on the wiring to support the junction box. Use appropriate fasteners to secure the junction box. Use screws or bolts that are long enough to penetrate the mounting surface and provide a secure hold. Do not over-tighten the fasteners, as this can damage the junction box. Follow the manufacturer's instructions for installing the junction box. The manufacturer's instructions will provide specific guidance on how to install the junction box correctly. When working with electrical wiring, always be aware of the potential hazards. Electrical shock can be fatal. Take all necessary precautions to protect yourself from electrical shock. Do not work on electrical wiring if you are not qualified to do so. Hire a licensed electrician to do the work. The NEC provides detailed requirements for the installation of junction boxes and other electrical equipment. It is important to be familiar with the NEC requirements to ensure that your electrical work is safe and code compliant. NEC Section 314.16 covers the requirements for box fill. Box fill refers to the maximum number of conductors, devices, and fittings that are allowed in a junction box. The box fill requirements are based on the size of the junction box and the size of the conductors. NEC Section 314.17 covers the requirements for cable entries. Cable entries are the points where cables enter the junction box. The cable entry requirements are designed to protect the cables from damage and to prevent moisture from entering the junction box. NEC Section 314.27 covers the requirements for outlet boxes. Outlet boxes are junction boxes that are designed to accommodate receptacles, switches, and other devices. The outlet box requirements are designed to ensure that the devices are properly supported and that the wiring is protected. NEC Section 406.4 covers the requirements for receptacles in kitchen countertops. The receptacle requirements are designed to prevent electrical shock and to protect against ground faults. NEC Section 210.52 covers the requirements for small appliance branch circuits in kitchens. The small appliance branch circuit requirements are designed to provide adequate power for the appliances that are typically used in kitchens. It's worth noting the importance of electrical permits. In many jurisdictions, a permit is required for electrical work, including the installation of junction boxes. Check with your local building department to determine if a permit is required for your project. An electrical inspection ensures that the electrical work is done safely and in accordance with the electrical code. After the electrical work is completed, schedule an inspection with the local building department. The inspector will verify that the work meets all applicable codes and regulations. Regarding specific appliances, it is necessary to understand the electrical requirements of the double oven being installed. Double ovens typically require a dedicated 220-volt circuit. Ensure that the circuit breaker and wiring are properly sized to handle the load of the oven. Consult the oven's installation instructions for the specific electrical requirements. When connecting the oven to the junction box, use the correct type of connector and follow the manufacturer's instructions. Ensure that all connections are tight and secure. Consider the use of flexible metal conduit (FMC) to connect the oven to the junction box. FMC provides a flexible and protective raceway for the wiring. When routing the FMC, avoid sharp bends that could damage the wiring. Use appropriate fittings to connect the FMC to the junction box and the oven. Regarding lighting in kitchen cabinets, if you plan to install lighting inside the kitchen cabinets, consider using low-voltage lighting. Low-voltage lighting is safer and more energy efficient than line-voltage lighting. Install a low-voltage transformer to convert the line voltage to low voltage. Use appropriate wiring and connectors for the low-voltage lighting. Consider using LED lighting as it is energy efficient and has a long lifespan. Think about installing a switch to control the cabinet lighting. The switch can be located inside the cabinet or on the exterior of the cabinet. It is crucial to use tamper-resistant receptacles (TRRs) in kitchen areas. TRR have a built-in safety mechanism that prevents children from inserting objects into the slots. TRR are required by the NEC in all new and renovated dwellings. When selecting electrical boxes and fittings, consider the material. Metal boxes are durable and provide good protection for wiring, but they can be more difficult to work with than plastic boxes. Plastic boxes are lightweight and easy to work with, but they may not be as durable as metal boxes. Select boxes and fittings that are appropriate for the application. When installing electrical boxes in walls, ensure that they are flush with the finished surface. This will prevent the cover plate from sticking out and creating a tripping hazard. Use shims to adjust the depth of the box if necessary. When installing electrical boxes in ceilings, ensure that they are securely supported. Use appropriate hangers or supports to prevent the box from falling down. When routing wiring through walls and ceilings, avoid drilling through studs or joists. If you must drill through a stud or joist, use a drill bit that is no larger than the diameter of the wire. Protect the wiring from damage by using nail plates or grommets. When working with electrical wiring in older homes, be aware of the potential for asbestos. Asbestos was commonly used as insulation in older homes. If you suspect that there is asbestos present, do not disturb it. Contact a qualified asbestos abatement contractor to remove the asbestos safely. Also, be aware of the potential for lead paint in older homes. Lead paint is a health hazard, especially for children. If you suspect that there is lead paint present, do not sand or scrape the paint. Contact a qualified lead paint abatement contractor to remove the lead paint safely. When making electrical repairs, use the same type and size of wire that was originally installed. Using the wrong type or size of wire can create a fire hazard. If you are not sure what type or size of wire to use, consult a qualified electrician. Always test your work after completing an electrical repair. Use a multimeter to verify that the circuit is working properly. Check for any shorts or ground faults. If you find any problems, correct them before using the circuit. Consider the use of smart home technology in your kitchen. Smart home technology can make your kitchen more convenient and energy efficient. Install smart switches to control your lights and appliances. Use a smart thermostat to control the temperature in your kitchen. Install smart smoke detectors and carbon monoxide detectors to protect your family from fire and carbon monoxide poisoning. Use a smart water leak detector to detect water leaks in your kitchen. Stay informed about the latest electrical safety information. The Electrical Safety Foundation International (SV) is a non-profit organization that provides electrical safety information to the public. Visit the SV website to learn more about electrical safety. Follow the National Electrical Manufacturers Association (NEMA) guidelines for safe electrical practices. NEMA is a trade association that represents manufacturers of electrical equipment. Visit the NEMA website to learn more about safe electrical practices. Remember that electrical work can be dangerous. If you are not comfortable working with electrical wiring, hire a licensed electrician. A licensed electrician has the training and experience to ensure that the job is done safely and correctly. Prioritize safety and ensure compliance with all relevant codes and regulations to ensure a safe and functional electrical system in your kitchen.